Honors Pre-Calculus students, these are your 9.2 notes. Today we're going to be looking at arithmetic sequences and also some sums. We'll have some formulas for you to look at, some patterns to consider. All in all, I think it'll be a good day. So, let's get this started. An arithmetic sequence is defined as a sequence where the difference between consecutive terms is constant. So the sequence a sub 1, a sub 2, a sub 3, on and so on is arithmetic if the difference between each of the consecutive terms would be constant. So that's what we're showing here. A2 minus A1 is the same as A3 minus A2, etc. We call that value D. So in other words, we're looking for a constant change, either adding or subtracting, if you wanted to think of it that way. Sometimes would work as well. So let's look at number 1, 7 to 11. Our change there is plus 4, 11 to 15, we're again going plus 4, 15 to 19, plus 4. So we would say yes, it's arithmetic, and the D value there is 4. Alright, so let's look at number 2. Again, we're looking for the pattern to see are we adding or subtracting the same thing, and in this case you can see we're going down 5 each time. So again, we would just say yes, and this time the difference is negative 5. When we look at number 3 though, look at the differences. Plus 3, plus 5, plus 7. These are all perfect squares, by the way, but there's no way around this. This is definitely not an arithmetic, or we think of it as linear pattern. Okay, last one like this, number 4. I hope you aren't too intimidated by the fractions that are going on here, but we can see that this is definitely linear or arithmetic because what we're doing is we're adding 1/4 each time. Up next, we're going to look at a couple of different formulas for how we find the nth term of an arithmetic sequence. The one on the left here, a sub n is equal to dn plus c, where c is equal to a sub 1 minus d. That's another way of saying the 0th term. It's kind of a weird word, but it's the term, if you went back one step before the first term, you'd take your first term and subtract the difference and you'd be there. I find that have this all separated like this is a little goofy. I kind of prefer the second option here. A sub n is equal to a sub 1 plus your difference times n minus 1. So when you do n minus 1 times the difference, that basically takes you back one step times the difference. The concept here is you're not adding d to find the first term. You don't start adding d till the second term. This moves you down one step and it works. So I prefer the second one. If you prefer the first, that's totally fine. Just make sure that you're comfortable with whichever option you use. I'm going to mostly stick with the second one, so follow along. Find the nth term of an arithmetic sequence where the difference d value is 5 and the initial is negative 2. So I'm going to go ahead and set it up like this. I'm going to say a sub n is equal to our a sub 1 term, which is negative 2, plus n minus 1. I'm just going to leave n minus 1 as n minus 1 times our common difference of 5. Now that matches the format we see right over here. With a small amount of simplification, we can make this look a little bit better. So this will be 5n. We'd have minus 5 and minus 2, so 5n minus 7. It looks a little bit cleaner, but it's the same thing as what we see right above. On our next slide, we're going to look at, first of all, I mentioned the recursive formula, a sub n plus 1 is a sub n plus d. In other words, if you want to know the 8th term, you take the 7th term and you add the difference. That's just the concept that we're considering. Now here it says that the 4th term of an arithmetic sequence is 20 and the 13th is 65. Write the first 11 terms. Now here's what I'm going to do. I'm going to look at the differences between the 4th and the 13th term. And I know that the 13th term is 65, the 4th term is 20, and so what we're doing is we're doing 9 steps to get a difference of 45, which tells me that my common difference there is actually 5. That's D. And again, that came from knowing that the fourth term, a sub 4, was equal to 20, and that the 13th term was equal to 65. Okay, so now what we need to do is we need to go ahead and we're trying to write the first 11 terms. In order to write the first 11, I kind of need to find the first term. So I'm going to do this. I'm going to say, well, I know that the fourth term is 20, so I'm going to use that formula that we see right up here. So what I don't know this time is a sub 1. I know that n is 4 minus 1, and I know that the difference, we found the difference to be 5. So this would be 15. If you subtract 15, moving fairly quickly here, you see that a sub 1 is equal to 5. When you couple those two pieces of information, the a sub 1 and the common difference, we can make our list. 5, 10, 15, 20, 25, 30, and so on. I would imagine some of you are saying, you know, Mr. Hale, I probably could have figured out without finding a sub 1 like you see that I did right here. You probably could have just kind of worked backwards knowing that difference. That's fine too for instructions like that if you are comfortable with that. I'm just showing you a method that'll work all the time. Alright, so here we go. Find the 14th term of an arithmetic sequence that begins with 5 and 12. Another way we're saying that is a sub 1 is 5 and a sub 2 is equal to 12. Now if you're really paying attention, that tells us right away that the difference is 7. Now you could go out and list 14 terms, but I'm going to suggest to you that we have a little bit better way if we think about it as an nth term situation. So I know that a sub 14 would have to equal a sub 1 plus n minus 1, now in this case n is 14, times our common difference of 7. So the 14th term is 5 plus, and 13 times 7 is 91, so that gives us 96. Alright, moving forward. So far, everything that you've seen, even without formulas, you'd probably be able to figure out the patterns and put things together and make it happen. One thing I don't want you to have to do, though, is to have to find sums of sequences that are really significantly big. So what we're going to do is we're going to look at some formulas. So here we go. Finding the sum of an arithmetic sequence. The sum of the first n terms is n divided by 2, and then you multiply by the sum of the first and last terms. Okay, so that little formula right there, it's basically taking the number of terms divided by 2 times the sum of the first and last. I think sometimes it makes sense when we get to number 9, it might help that formula make a little more sense as to why that works, where you're adding the two n's together. Alright, so here we go. Let's look at number 8. It says the sequence is 1, 3, 5, and so on to 19. Alright, so we're talking about how many terms do we have here? Well, I know that the first term is 1, and I know, and you could figure this out a few ways, but 19 is actually the 10th term that we have going on here. So we're trying to find the sum of the first 10 terms. We would just simply do 10 divided by 2 times the first plus the last. That's 5 times 20. So the sum of the first 10 terms is 100. That's not too bad now, is it? Alright, let's take a look at number 9. Find the sum of the integers from 1 to 100. I'm going to go ahead and list this even though it may seem kind of obvious. A sub 1 is 1, a sub 100 is 100. That gives me some important information. It tells me number of terms would be 100. It also tells me that our first term is 1 and that our last term is 100. So really what we have here is 50 times 101, which is 5,050. We're going to use that same formula for a problem like this. It says find the 150th partial sum. And here's what I know. I know that a sub 1 is equal to 5. And I know that the common difference here is 11. What I don't know, well, I do know that we're finding 150 terms, the sum of those, but before I can actually use the formula for the sum of the 150 terms, I need to actually find the 150th term. So I'm going to do a sub 150 would be equal to 5 plus, and it's 150 minus 1 times 11, and that gives me 1,644 for my 150th term. All of a sudden this problem just got a lot simpler because we can just do the sum of the first 150 terms would be 150 divided by 2 times 5 plus the last term, which is 1644. And I did not do this one in my head, but my calculator tells me the answer is 123,675. Again, that one you could do by hand if you'd like, but I don't think that would be very fun. We have formulas to make our lives easier. Let's use this formula for a seating capacity problem that you see here. We have an auditorium where there are 36 rows. The first row has 15 seats, then 18, then 21, and so on. So let's think about, what do we know? Well, 36 rows is our n value. That's the total number. That would be like the number of terms in our sequence if we were thinking of it that way. I know that a sub 1 is 15. That's the first row. Now before I can find the seating capacity, I actually need to find how many seats are in the last row, and to do that we do a sub 1, which is 15, plus n minus 1 times our difference. Now we didn't write our difference over here, but you can see each row has 3 more seats than the previous. So our 36th row would have 120 seats. And now we can just go to the formula. S sub 36, the sum of the first 36 rows, would be 36 divided by 2 times the sum of the first and the last, which in this case would be 15 and 120. And we have 2,430 seats. A lot simpler than adding those 36 numbers up together. Now for our last problem, we have a bit of a physics application here. A skydiver drops a marble during his jump out of a plane. So during the first second, the marble drops 16 feet. During the second, the marble drops 48. During the third, it drops 80, and so on. If the pattern continues, how far will the marble drop in 10 seconds? So we'd have to add the sum of those first 10 numbers in the sequence. So let's take a look at this. So again, we're talking about the marble. We know, first of all, we know that it drops 16 feet in the first second. We know that it drops an extra 32 feet during the second. That would be, well, 48 total, which is 32 more than the first second. And then we also know our n value here. We're looking for 10 seconds. Now again, before we can use our sum formula, I need to find the last term. So a sub 10 is 16 plus 10 minus 1 times our common difference of 32. So in the 10th second, that marble was dropping a football field and then 4 feet, 304 feet. So here we go. To find the total distance the marble drops in 10 seconds, we would do 10 divided by 2 times the first term, which is 16, or the first second, how far it drops, and then the last term, 304, which gives us a grand total of 1,600 feet. All right, folks, that wraps up the notes for today. I know that this is a little bit crazy that you just saw this formula, but here it is, so try it in class, maybe. All right, that sounded good in my head, but it sounded lame. Have a good one, folks.